Hello guys, welcome to another exciting installment. We're going to be doing UH Quiz 23, FTOC number 1. What's up? You're going to love it because I think you guys are all stars and you'll be alright. Alright, let's go ahead and start. So here we go. Given that we have the area under the curve from 0 to 1, yeah, there's funny formatting going on. My apologies, guys. 0 to 3 of that same function is 5, 3 to 6 of that same function is 4. They want the area under the curve from 0 to 6. So just look at it and think about it for a little bit. If I find the area under the curve from 0 to 3, and I add, see, so where this one stops, this one starts, and I add the area under the curve from 3 to 6, that will give me this one. So I'm going to take the 5, area under the curve from 0 to 3. I'm going to take the area under the curve from 3 to 6, which is 4, and I add them up. And there you go. And yeah, it is that simple, guys. So don't make it complicated. It's not that bad. All right, let's see. This one says, given that x is greater than negative 3, so I have this function. It's an integral defined function. And they put a 3 in there. So let's see. F of 3 is equal to the integral from 3 to 3 of t square root of t plus 3 dt. Well, you haven't moved, guys, so check it out. Lower limit is 3, upper limit is 3. Because you haven't moved, 0. Sorry, guys, I had some pizza, and now I'm burping and all that good stuff. All right, let's go to the next question. It says, find the area of the, given that x is greater than negative 8, find, and f of x is integral from 3 to x, t squared to t plus 8, find f prime of x. All right, so hopefully, well, we haven't covered it yet, but we will be covering it on Tuesday. So that's why I'm making this video, because I'm going to assign this quiz on Tuesday. But hopefully you guys that are not in my class have covered have covered the topic fundamental theorem of calculus. And what the fundamental theorem of calculus states is that anytime I take a derivative of an integral, I can have any constant on the bottom. So I'm going to put 3xt square root of t plus 8 dt. So that means when I'm taking the derivative of this integral, all I got to do is make sure that I have an x at the upper limit. So derivative of the integral, that pretty much cancels itself out, and wherever you see a t, you're going to plug in an x. So that equals x square root of x plus 8. So I look for that, and there it is. And there is the proof behind this, guys. Hopefully you guys have covered the proof. Worst case scenario, you can just follow this, and it makes sense. Taking a derivative of an integral, antiderivative and derivative kind of cancel each other out. So it makes sense in that way, but there is a neat little proof that I think you would enjoy, so check it out. All right, so this one says f prime of 4. So first thing you do is you take a derivative, because, you know, that's what you got to do. So first, find f prime of x. So we're big F prime of x. So here we go. I have a constant on the bottom. I have the variable x on the top. I can take a derivative. So f prime of x is equal to x square root of x plus 7. Wherever there's a t, you're going to plug in an x. So now I'm going to insert the number 4. F prime of 4 is equal to 4 square root of 4 plus 7. So let's see what that is. 4 square root of 7, 8, 9, 10, 11. So there it is. All right, let's go to the next one, guys. This time they want f prime of 2. So again, we find, well, the upper limit is x, the lower limit is a constant. Perfect, that's what you need. So we take a derivative. Wherever you have a t, you're going to plug in an x. So 1 over x squared plus 9. And now this says 2. So f prime of 2 is equal to 1 over 2 squared plus 9. 2 squared is 4. 4 and 9 is 13. So 1 over 13. Go to the next one, guys. All right, so this one wants the second derivative. So upper limit is x, lower limit is a constant. So here we go. F prime of x is equal to 1 over x squared plus 1. And I guess to make life easier, guys, I would write this as x squared plus 1 to the negative 1. And now, check it out. F prime of x is equal to, so move the negative to the front, x squared plus 1, close it, put a negative 2 because we're subtracting 1 because we're taking a derivative. We're not done. Chain rule times 2x. So let's fix this. So, I don't know why it's acting up like that, guys. F prime. Yeah, what's going on? All right. Doesn't want to write. I guess I'm running out of ink again. All right, let's see. Negative 2x over x squared plus 1. And then that has a square on it. And then I look for that. And there it is. All right, let's go to the next one. Same thing, but notice or observe. Well, there we go. Observe that I cannot take a derivative just yet. I need to switch out these guys. I need to have the x on the top and I need to have a constant on the bottom. So when I do that, here's what I'm going to have. A negative integral 0 to x of square root of t squared plus 25. And then I write the dt there. So now I'm ready. I just used the property. And now when I take the derivative of this, so here we go. F prime of x is equal to, there's my negative. And then wherever you have a t, you're going to write x. So x squared plus 25. And we're not done yet. We're going to have to take a second derivative. So let's write this like this, guys. And that's going to make life a lot simpler. So f prime prime of x is equal to, bring that half to the front, negative half x squared plus 25. Subtract 1 from that half, so that turns to a negative half. And we're not done. Chain rule times 2x. So let's see, that half and that 2 cancel each other out. I'm going to have a negative and then x on the top, and that's negative 1/2. That means you bring it down. Square root of x squared plus 25. And there it is. All right, let's keep going. All right, I have a variable on the top. This time it's not x, it's x to the 10th power. So I'm going to have to do chain rule, and it wants find the derivative of f of x. All right, so here we go. F prime of x is equal to, wherever you have a t, you're going to substitute x to the 10th. X to the 10th sine x to the 10th. But here's the key. Since the upper limit was not an x, guys, we have to do chain rule. So now you're gonna have to say times the derivative of x to the 10th, which is 10 x to the 9th. And remember, we followed protocol. The lower limit was a constant, so that means we were able to take this derivative, or else we wouldn't be able to. So f prime of x is equal to, let's see, 10 times 1 is 10. So 10, and then x to the 10th, x to the 9th, that's x to the 19th sine of x to the 10th. And we look for that. All right. Hold on, guys. I'm having some technical issues here where I'm not even able to scroll. Let me see. Maybe if I disconnect this power, that'll be better, maybe. All right. Question 9. I don't think it's better, actually. It got worse. All right, let me connect it back then. All right, question 9. So again, same thing. I have a lower limit constant. Upper limit has a variable x, but it's not just x, it's x sine x. So that means we're going to have to do chain rule. So here we go. F prime of x is equal to, wherever there's a t, you're going to plug in the entire expression that you have up there. Square root of 49 minus, open parenthesis, x sine x, close it, put a square on it, and we're not done, times the derivative of the top. So we're going to go first, x times the derivative of the second. The derivative of sine x is cosine x. And then I'm going to write plus the second sine x times the derivative of the first, which is just 1. Leave it alone. And they probably wrote this in the front. Yeah, there it is. The x squared and sine x squared, guys, all they did is just use that little property. So bring the 2 there, and then bring the 2 either right on top of the n, or put sine x in parentheses with a square on it. All right, last question here. It says, find the formula for f of x given that f is continuous. All right, and this expression. So notice what we want is f of x. At the moment, I have the integral from 0 to x of f of t dt. So I have a constant on the bottom and an x at the top, and we should observe that if we take a derivative, this would turn to f of x. So let's take a derivative of everything, guys. Negative 4x to the third plus 2x minus 3 equals f of x. And then I just look for that. Yeah, it looks like that's it, guys. I think you guys are going to have a good time on this one. Hook me up with a thumbs up. I would really appreciate it. And hopefully you guys enjoyed this one. And I'll see you guys in class, or maybe you guys are in class. So hello. And all right, let's just take care of business. All right, later, guys. Bye.